charger in your office. So
Mm-hmm.
I go plug it in.
Mm-hmm. Okay, so if we want to know what production levels result in the company taking a monthly loss, what's that going to be?
0 to 149.
Yeah. So, I would probably just say like up to 150 items. Definitely, of course, has to be greater than 0. If you didn't say that, I probably wouldn't throw a fit about it because it's sort of assumed, right, that we're not making negative items, right? And you're right that it's really like up, I mean, it's through 149 because we're not going to make 149.5 items. Based on the graph, this is continuous, even though realistically it's not actually continuous, right? Realistically, like, there would be a whole bunch of dots. Like, there'd be a dot at 1, a dot at 2, a dot at 3, a dot at 4, because we're not making parts of items, right? We're not going to make like 4.5. But that can be a little cumbersome. That's a lot of dots. So that's typically why they make it look continuous, even though it's not. So if you had said through 149 items, that wouldn't be incorrect, because we know we're not making like 149.572 items. So let's fill in this table. Let's see, so we're just using the graph. So R of 0 is going to be 0. That's this point right here. And then C of 0 is this point right here, which is at 100. And then we know that P of X is revenue minus cost. So P of 0 is going to be 0 minus 100. Did you find it? Okay, good.
Also, just knocked over your chapstick. I'm sorry.
It's not my chapstick. You're cool. I don't, it's been there for like months. I have no idea where it came from. So go ahead and do the same thing for production levels of 100, 200, 300, and 400. And then sketch the graph of P of X. And then we'll have a look at it. 135. Okay, let's plot these guys. Yours might not be exactly the same as mine, and that's okay. Like, just, remember we're counting by 20, so if it's halfway between two lines, if it's halfway between the first line and the second line, above, 100, it would be, 130. So, let's see, negative 100, down here, negative 35, so 20, 35 is about right here. 40 is right here. 135 is right here. And 245, 45 is right around there. This graph is a little bit misleading because it looks like it could be a straight line. It's really not linear. And the reason we know it's not linear is because revenue is linear, but cost is clearly not linear. And if you combine a linear function with a nonlinear function, if you add or subtract those, you're not going to get a linear function because there's going to be an x squared or something. It does appear linear because it grows so slowly. If we were to extend this out, it would likely start to get steeper and steeper and steeper. So just a couple things to notice. If we look at our answers to A, B, and C, notice that P of X is less than 0 when X is between 0 and 150. Right? So that was our part C where we said we were going to take a monthly loss. So from 0 to 150, that means that our profit will be negative. That represents our loss. P of X is equal to 0 when X is equal to 150. So that's the point where we break even, right here. And then P of X is greater than 0 when X is what? Yeah, greater than 150. And that corresponds to our answer to A. So this function allows us to see all of that same information without having to work with two separate functions, right? It shows us when we're making money, when we're breaking even, when we're losing money as a single function. And so that's kind of the power of these combination functions, is that we can take two relationships and combine them into a single relationship so that we're not always calculating two different things and trying to put them together. We just have one relationship to tell us everything we want to know. There should be an arrow on this. I apologize. Here we go. So any questions about, as far as last night's homework, as far as evaluating, using a graph or a table or just anything from part 1 of 6.1 before we move on to the difference quotient that came up on the homework? You guys feel pretty good about it?
You explained it in a way at the beginning of class that made a lot more sense than the video notes that we did. From my understanding of it, somehow I thought that you multiplied the equations together when it was f of g times each other or something like that.
So you do, you multiply the expressions together. So if I have f of x equals 3x and g of x equals x plus 1. So this right here is the output of g. and this is the output of f. So when I do f times g of x, I'm multiplying the output of each individual function. So f of g times g of x. So when we don't have specific inputs, then we take 3x and we would multiply it by x plus 1. So it's sort of like we're multiplying the equations, but you kind of just want to think of them as just as expressions that represent the output of each individual function. So to get the new output, you just take the output of each one and perform the operation on those.
Oh, that makes, yeah.
Cool.
That makes more sense.
Good. Okay, you guys ready for difference quotient? Okay. So we're going to start with just evaluating a little bit. So we already know how to evaluate functions. Remember that what is in the parentheses here represents the input of your function. And that if we change what's in the parentheses, that means we want to change what is in the rule to get the output exactly the same way. So if I'm given f of 4, we replace the x in parentheses with 4, which means on the right side I'm going to replace all the x's with 4. So equals 3 times 4 minus 4 squared. So negative 4, 12 minus 16. The same is true if my input is not a number, but like an expression. So if I want to evaluate for a plus 5, going from f of x to f of a plus 5, the x was replaced with a plus 5. So on the right side, I'm going to replace all of the x's with a plus 5. So 3 times my input minus my input squared. And we're not simplifying at this point. We're just showing how it gets plugged in. So remember way back when we first started talking about functions and I told you guys to try not to focus on x, right? Remember when we were describing functions like in words? We want to focus on the operations the function performs as opposed to like the x, because then we can think of it as like this function multiplies the input by 3 and then subtracts the input squared, and then no matter what we decide our input is, no matter how weird it is or how big it is, we just perform those operations on it. So we multiply a plus 5 times 3 and we subtract a plus 5 squared. Here in this, I don't really like how close I got to that. So on this third one, what is the input of f? Yeah, it's just t, and all the other operations are happening outside of that, right? Remember when we did transformations, we talked about if you're acting on the input or if you're acting on the output. So like for the first two, all we were doing was changing the input, and so we used the same operations in our function and just put in a different input. Here we're going to use an input of t, so that's 3 times my input minus my input squared, but then we have to multiply that, so that's f of t. We're going to multiply that by 2 and add 5. Right, so again, we want to think of f of t as just the output that you get when you evaluate f for t, and then we can treat that output like a number. We can multiply it by other numbers, we can add it, whatever we want, because all those operations are happening outside of that function. So we're going to work on simplifying what's called the difference quotient, which is this expression right here. The difference quotient is always the same. And I think you guys saw last night in your video notes like where the difference quotient comes from, right? It's just a general formula for the average rate of change of a function between 2 points that differ by h, whose x values differ by h. And this is the basis for the definition of the derivative. So when you get to calculus, you'll be using the difference quotient quite a bit. So we just want to work on the algebra of like evaluating it and simplifying it, so you have that part down, and then when you get to calculus, you can see it kind of conceptually and how it leads to the derivative. So we're going to start by finding and simplifying f of x plus h. So again, we're saying evaluate the function f for an input of x plus h. So I want to multiply my input by 3 and subtract my input squared. Notice that we are not writing f of x and then writing plus h afterwards, right? So the input itself is x plus h, which means whatever operations the original function performs on x, I am now performing on x plus h.
Where's the 3 coming from?
Right here.
Oh, okay. Oh, we're using that. Okay.
Yep.
Yeah.
So our function tells us multiply 3 by the input and then subtract the input squared. And so I multiplied 3 by x plus h and subtracted x plus h squared. If you find yourself getting like tripped up and like evaluating this incorrectly, one surefire way to evaluate functions is to write the function exactly as it is. I don't know why I made that red. So write like f of x equals 3x minus x squared. And then put parentheses around your x's. And like then literally take your eraser and be like, this change to x plus h, this change to x plus h, this, I'm sorry, it's very smushed. But does that make sense? Like you can like write exactly what they give you, put parentheses just around the x's, and then erase those x's and replace it with whatever's in the parentheses next to the f. So now let's simplify. We have to be careful with that x plus h squared because notice we're also subtracting. So there's 2 things we have to do to get rid of parentheses. We have to distribute x plus h times x plus h, but then we also have to distribute the negative. So that means when we multiply x plus h times x plus h, we're going to keep it in parentheses because I haven't yet distributed that negative. So we've got 3x plus 3h minus x plus h times x plus h minus, so this gives me x squared plus 2 times xh plus h squared. And now to get rid of the parentheses completely, I'll distribute the negative. So we get 3, I forgot my equal sign, sorry. 3x plus 3h minus x squared minus 2xh minus h squared. This looks really messy right now, but I promise it ends up getting very nice at the end. So next thing we're going to do is we're going to use what we just found and we're going to subtract f of x from it. So f of x plus h is what we just found. So 3x plus 3h minus x squared minus 2xh minus h squared. So that's my f of x plus h. What is f of x?
3x minus x squared.
Yep, and again, we need those parentheses. So that f of x part, you're just like literally copying the original function rule. And now to simplify that, I'm just going to distribute my negative. So I can drop parentheses here because there's nothing to distribute to the left of that leftmost set of parentheses. Or not set of parentheses, but parentheses. So 2xh minus h squared minus 3x plus x squared. And now something really cool happens, which should happen every single time you do this, which is that we notice that 3x minus 3x is 0, and that negative x squared plus x squared is 0. So all of the terms that do not contain an h should end up adding to 0. If they don't, you probably forgot to distribute a negative somewhere. That's the most common error that causes that problem. So don't just assume they're going to go away, because actually making sure that what you've written actually gets you 0 is a good way to check to make sure you've got all your signs right to begin with. So we end up with 3h minus 2xh minus h squared. And then the last thing we're going to do is we're going to take that f of x plus h minus f of x, and divide it by h. So we've got 3h minus 2xh minus h squared over h. Now remember, we cannot just cancel an h because we can't cancel terms, right? Just like if I had 3/4 and I wrote that as 2 plus 1 over 2 plus 2, that does not mean that 3/4 is equal to 1/2, right? Because that's illegal. There's addition between those, the 2 and the 1 and the 2 and the 2. You only get to cancel factors, so things that are involved in multiplication. So in order for us to cancel that h, we need to factor a GCF of h out of the numerator. So we're going to write the entire numerator as h times another polynomial. So we have h, we're just undistributing the h from all three terms. So 3 minus 2x minus h. And now I can cancel that h because in the numerator, the only operation that h is involved in is multiplication. There's no addition or subtraction outside the parentheses. And so now I can cancel that because h divided by h is 1. And that gives me my final answer, which is 3 minus 2x minus h. So there's a bit to it, but at some point you start to realize that this is going to simplify really nicely. And if it just gets messier and messier and messier as you go back to the beginning and start over, because it probably indicates some sort of error. It starts out getting pretty messy, but then it should start to die down towards the end and get a lot simpler. So the things that you're looking for as far as just checking to make sure you're on the right track is at the end of this step, every term should contain an h, which allows you to cancel an h in this step. So if those things don't happen, it's a good idea to go back and check your signs, especially because signs are usually what causes that problem. If you find yourself getting 1 every time you do a difference quotient, then you are adding h at the end of f of x instead of plugging f of x plus h in, right? So if you just take 3x minus x squared and add h instead of actually plugging x plus h in for x, you will always get 1. So if that happens over and over again, let's sit down and go through a few together to make sure we're evaluating correctly. Hey, that's the same page. Is that the next page? Okay.
Yeah.
I thought I skipped one. Okay, so you guys try these ones. Yes. Actually, let's see. If you're still working, that's fine. I'm just gonna write down the answers so you can start checking them. Okay. So, like I said, you can do this in pieces. I prefer to do it all as one expression only because, like, I think it's easier not to lose track of things if you keep it all the way through. But you can do it in pieces like we did this first one, as long as you label each piece. So, I don't want to see this step turn into this step like halfway through because you're like following your train of thought. Like you want to make sure that everything is labeled accurately. So you can definitely do it in smaller pieces if you'd like to. It's totally up to you. But make sure that everything is accurate as far as your labeling. So every time you add another component, you add another left side saying what that component is. Does that make sense? Okay, so go ahead and check this one and ask me any questions you have. You all feel good about that? You all get it? Good.
I'm copying it down so I know how you do it.
Sure. So this is definitely something you want to like get some practice on. So that's why we have a written assignment tonight. Actually, I don't think it's in the written assignment. I think the written assignment is just graph. It's really funny. Your written assignment says part B on it. I have not found a part A anywhere in my like files of like materials, so I'm not sure what part A was. But nonetheless, there's a lot of these on your online homework. Make sure that you're really writing out the steps exactly like you would on a test, so that you don't get into like bad habits of like being sloppy with your notation and then end up doing that on the test, because that'll be unfortunate. Okay, are you good, Orlando? You got it. Okay. Okay, so let's talk graphs. So when we look at the graph of a function, we can pick a single point on that function or on that graph. And if the x-coordinate of that graph is 5, we know that that means that the horizontal length from here to here is 5. And if the y-coordinate is 3.5, we can say that the height of that point from the x-axis to the point that's a length of 5, right? That distance. So we're going to transfer that idea into function notation now. So when we say that y equals f of x, what we're saying is that the y-coordinate, so the y-coordinate, I don't know why it's red. So the y-coordinate is the output of the function evaluated for the x-coordinate. So if the x-coordinate is a, then the y-coordinate is f of a. If the x-coordinate is 22 billion, the y-coordinate is f of 22 billion, right? So when we write this ordered pair this way, all we're saying is that we got the y-coordinate by evaluating the function f for an input of a. So none of this is different from what you know about graphs already, except for the notation. So we're just expressing y as f of a instead of as y, because that tells us what x value it corresponds to, as well as what the y value is. So the length of this distance here, just like here it was 3.5, that distance is going to be f of a now, right? Remember that f of a just represents some number. We don't know what it is, but it's just some number. So we're going to use this to label some graphs. So we're going to start by plotting and labeling the point 2, f of 2. So my x-coordinate is 2. So I'm just going to find the point on the graph that corresponds to an x-coordinate of 2. So this guy is 2, f of 2. Now we want to label the length f of 2 on the graph. So remember that f of 2 is just the height of that point. And so from here to here, that length is f of 2. And then we want to make a tick mark on the y-axis to indicate that value, right? So just like here we had a tick mark for 3.5 that corresponded to a length of 3.5 that corresponded to a y value of 3.5. Those are all just the y value, like different ways of representing the y value. Same thing here. These are all just different ways of expressing f of 2, which is the y value of that point. So if you were going to look at this and try to make some generalizations, notice that that label, this coordinate, I forgot the other parenthesis up, and this length are always the same, because they're all just different ways of representing the y value. Okay, you guys try it with -1. We just have one slide left, and then we're going to work on.
Is this just one here?
Yep.
Okay. I think I got everything else.
Yes. Good.
That was the
Oh, and then this one.
Oh, I didn't see it. Is it asking for the distance?
Yeah, between the two x values.
So like 1 plus 1 plus h over 2. That's crazy.
So if you walk 10 miles, or if you walk 1 mile, pick up your friend and then walk 10 miles, how many miles did you walk? I need to say that again.
Okay.
If like school is 10 miles away from your house, and you leave from your house, pick up your friend 1 mile in, how far did your friend walk?
1 plus 1.
So don't look at the 1 and the h. If this is at 10 and this is at 1, what's the distance between them?
9.
Yeah, we don't add them, right?
No.
We subtract. So what's the difference between 1 plus h and 1? There you go.
That was almost bad. That didn't fall out.
And we have no paper towels on this campus either, so when we spill something, it's extra disastrous.
Do you have to call maintenance? No.
Well, I mean, we have
Pull the fire alarm?
we have a roll of paper towels down in our office, but I've been in other buildings and people have spilled things, and I'm like,
Aren't you not supposed to have food or drink in any classroom?
I've never heard.
There's
of
like a bunch of signs in the lecture halls.
that. You're not supposed to have food or drink in computer labs for sure.
That's valid.
I think they could try to say no food or drink in lecture halls, but that's not.
I mean, yeah, I eat breakfast. This is supposed to be my first class.
Yeah, so just that height.
It's
right
probably
there.
Oh, okay. So that would just be was it Lewis? No, not Lewis. Meriwether 101 or something like the big lecture hall. It's a huge one. Right? Meriwether. I think it was Lewis.
Every time I go give a test in a lecture hall, there's like a huge box of water bottles in the front,
Yeah.
like that people have left behind. So if you ever need a water bottle, just like sneak on up before class. Okay, so the difference in our x values is what?
It's 1 plus h and then f of 1 plus h.
So I mean right here. So just the difference in our x values.
Oh, plus h.
Yeah, just h, right? And then what is this distance right here?
Just 1.
F of 1, right? Because the x coordinate is 1, the height is f of 1. And then, so what is this height? Also f of 1, yep. So this point is 1f of 1, if it helps to label the point with the ordered pair first, even if it's not asked for. So then what about our second point right here? What's the x-coordinate?
1 plus h.
Mm-hmm. And the y-coordinate?
F of 1 plus h.
Yes. And so the height of that point is
F of 1 plus h.
f of 1 plus h. Good. Be sure to just distinguish between what is a height and what is a horizontal distance to help keep track of your x's and your y's. So anything that is in this first spot will only correspond to things down here, and anything in the second spot, that'll correspond to things over here. So kind of think horizontal, vertical. Any questions before we start on your homework? So your homework, the worksheet is actually in your packet of notes. It says,
Question homework part B.
yes, part B. You got 100% on part A. Congratulations.